Is there a TV running? Is that, do you hear it?
Yeah, I don't know what that is.
Okay. But you do hear.
Yeah,
yeah.
It's not too distracting.
Yeah. Oh, well.
Yeah.
Well,
I was waiting at the wrong room.
okay. Okay. So it's only today, or you're going to be able to make it?
Today and possibly a couple of other days that we have.
Okay.
But I don't have Monday classes.
Okay. It is. Ah. Permanent markers are not supposed to be used from this way.
Yeah.
No. Okay. I used. Okay.
I bet if you hit that with that cleaner,
This one? Oh,
yeah, one of those cleaners will probably come off.
Anything with alcohol and just get it out.
the napkin here. Perfect.
It was a much different experience coming onto campus compared to last fall.
For once there was more cars.
Oh,
So like,
it was a cars were backed up all the way to the main road coming around to get into the parking lot for a student center.
wow. So you must be Hruday?
Yeah.
Yeah, okay. So you're new, right? Have you settled down?
Yeah, but some things are not very yet, but I will quite well settle down.
Okay, okay.
Thank you for asking.
And you're coming from
Bangladesh.
Bangladesh, wow. So that's a big settling down, significant, yeah. This is Ken. He came last year, right? Last semester or last semester. And that's Rob. He also came 2 semesters back. Yeah, I think you guys will. Ken, yeah, K-E-N, Rob. Yeah, 3-letter, simpler names. And you're Hruday, right?
Yes.
Yeah, maybe you want to help them with your name.
Yeah, not very good. I think they can call me John.
Johnny.
My name is Vijoy or John.
Oh, John. Okay, good. Okay, that makes it easy.
Yeah, it's easy to pronounce.
Yeah. I mean, at least for those who are. But Hriday, I think, means heart, correct?
Yeah.
Yeah, Hriday in, I think in his language means
You
heart.
understand Bengali?
No, Hriday, the word is Hindi. Yeah, I understand. Ekta both. So I stayed in Kharagpur for 2 years, so I picked up a little bit. Yeah, yeah, Kolkata. Yeah, like it's 2 hours, a very remote village there. Yeah, yeah. So yeah, yeah, that place had a smaller population than Carbondale. So yeah, so Carbondale is bigger city for me. Yeah. Okay, let's see. So it is. So Hriday, I think Ken and Rob know this. We'll be recording the lectures. It's primarily because one of us, Rob, actually may not be able to attend all the classes because of conflict. And I changed the classroom. If I don't know whether you were in that email list about 2-3 weeks back, I wrote an email saying that I will be changing the class. Earlier it was scheduled to be on Tuesday. And that was because there was a conflict in schedule with my schedule. So overall, and last year, because of the pandemic, we recorded the lectures because they were attending using Zoom, and based on feedback, it seems it benefits. So hopefully it will be useful. And the main point here is that if you have any reservations about that, you should write to me, contact me. And if you don't, I think it's just be professional in this, be aware that you're being recorded. It is not put in a public setting. It's not available in a public setting, but be aware that with a link, it is pretty much public. So once you're recorded, it stays somewhere or the other. And so be aware of that. But I think for us, usually it is not a challenge, but as a disclaimer, I think I should state that. So do feel free to raise your concerns.
You will find it very helpful when you're working on homework and you've written something down wrong, to be able to go back to that portion of the lecture and go over something.
Yeah. I should pass on this.
I think Jordan last year would just listen to your lectures while he was doing other things.
Yes. The best was we have Jordan. He's another grad student. He's it might be okay to say he's part-time, like Rob. Rob also does a second job with this, and Jordan also does a second job. So once he attended the class while he was, what's the right word for it? He was replacing a floor, and he's into construction or work, or he supervised.
The flood in the basement too.
Yeah, one of his apartments had got his basement flooded or something like that, and he was helping that. So if he had put the mic on, it would be really loud, I suppose, but he was attending the lecture. I don't know how that happens, but that's a good small story. So this is the syllabus.
And of all the different forms of alternative learning that we had last year, the recordings were the most effective, we felt.
So the suggestion is that it should be continued, and this time there is a real reason for it, because and not only my schedule and Rob's schedule doesn't work. But maybe in the future that would be an easy way to incorporate.
I'm especially supportive because there might be times in the future that my schedule sometimes.
I'm told we have one more student enrolled, so maybe, yeah, maybe, I don't know whether today is coming or not. Let's see. Oh, we're setting the camera. Okay, let me, I think we're, yeah, way beyond that time. Yeah, so let me go over the syllabus, even though for Rob and Ken, they have taken my courses before. The logistics remains pretty much the same, but still let me go over it in case there is a small change. So first of all, this is Physics 500A, mathematical methods. And I am can ignore the KV. I think it seems like it's a last name. So it's, even when you're talking, you can call me Shajish, or if you want to add a Mr. or anything before, that's also okay. Just, I think Hriday will understand. This is not my last name. Technically, like if you go by within my family, this is my actual name. So this is actually, this is my father's surname. That's my mother's surname. But I think in certain languages, like when you say that son of, like Rob, son of, let's say William, in some languages you would say William, father of Rob. That's more common. So it's the order of, I think the best example I have is that if you're familiar with Star Wars, there is Yoda. He speaks in a different way. He will say, the dog is running. He would say that running the dog. It's, I think, the subject and the verb. So I think some of the Indian languages, not all Indian languages, some of the Indian languages have this reversed feature in that. Mine comes in. I typically don't tell it because it's very confusing, especially when it comes to some bureaucracy. Oh, what's your name? This or this, and I try to explain them, and it never goes through. So just stick to Shajish. That's it.
We actually had that discussion the first semester.
First one I did have.
How we were addressing it.
Yeah, okay, I did mention it.
And
Okay.
that's actually common. I know that in Korea, China, they have the family name is first.
That's exactly, yeah. So that's what it is, and yeah. Okay, so a few things that will be useful in this course as far as website goes. We have, you can search my name in the department and it takes you to the same place, but course materials will be available on this website, and I think it is, if you just type this and then you will find a link to that, but otherwise more concretely it is 20. That's a year, that's the fall semester 08, and then that's a course name. I thought that if you go there now, it might be just homework 1, and most of the things that's needed for the course, you'll at least have a link there, if not the material itself. So that's a go-to place. Typically, you have D2L for this purpose, which is good, but I have found it very convenient to keep this. It also has this downside that when D2L is down, then the university is responsible and they will take care of something. But here, if this website is down by any chance, then it is my responsibility. So it comes with some baggage. So what I suggest is that when you won't have too many stuff, whenever you have the ability to download things, it's mostly the homework. And as far as the lectures go, though, they go on YouTube. So just be familiar that at the last moment when your exam is due or the homework is due, your internet may not be working. So depend on traditional stuff. There's a graduate level, I think, print your homework and other things. So I would put the responsibility on you guys and save myself out of it. So download stuff, that's my recommend. But having said that, it has hardly happened. It was only once that I had to really overnight I had to move the whole website to another place and then give some consideration that, okay, remove the deadline and all that. But it was, and that was because it was an exam. If it's a homework, I just postpone the homework. So that's easy. But typically, again, I don't have to be panicking about that, but it's a good idea in general. Office hours, I recommend you guys meet with me. This is a small classroom. The recommended hours are this. You will always find me in the office at that time. If I'm not there for a minute or so, just wait and I will be there. But this is a small graduate level classroom. Feel free to drop by anytime. If you see my door open or even otherwise, feel free to knock at my door and that's perfectly fine. Most of the time, the conversations don't go long, but you'll be surprised that just a small conversation could be way more efficient than actually you guys struggling. Having said that, it is also true that struggle also is okay because you learn that way. Making mistakes is the way to learn. At least that's my philosophy, that as far as mathematics and physics goes, it's like many paths reaching the same point. If you're not made mistakes, probably you missed on something. You're not learned certain things. So that's it. But at the same time, you have deadlines and other things. So it is good to ask questions, especially if there is a typo in a homework. If you come to me, oh yeah, this is a typo, that's okay. Again, if it's a typo and you struggled, probably it will help you, but maybe in a very long run, it might help you. Sometimes it may not be easy to realize that might even be helpful. So I would suggest that feel free to come and meet me. I'll encourage that. And in general, it has been a good experience for both, I think, for the students also, and surely for me, so it makes a difference. I'll encourage a meeting in the office hours, even if it's a trivial thing, or the typo, it's a factor should be 4, not 2, and it does happen. So I do say, accept that does happen. So feel free to. And talk to yourself also, among you guys also, feel free to talk. I'll completely encourage that. Talking about that homework, it is okay to talk to each other. That is, it's not cheating if you talk to each other. And in fact, you can look into others' homework. Like if there are 2 students, A and B, they can look into B's homework and they can actually copy down that whole process into your notebook. And that's also okay. Even without understanding, you copy down. It seems very ridiculous. But what I would suggest after that is that if you have taken any help, even internet is okay. So the point is, how you want to gauge yourself is, I teach, and then you open the homework and you're able to work out the homework. That means you're pretty good. You're in good shape. You may not even be, it is not even necessary for you to work on the course. You can take the exam probably. But if you have used the textbook, even including the textbook, that's a resource, internet, or you talk to a friend, or you copy down your friend's homework, the extent to which you depended on it should tell you how much prepared you are for the course. If you take the homework now and you don't understand, oh, what is this all about? I don't even understand the notation. That means you need to open the textbook, right? You need to concentrate more on my lectures, or you need to use the resources out there on the internet. More than the internet, I would recommend that go to the library, pick the topic, and just first of all, look on the internet, which are the classic books for this subject. Just check out a few books, and that's a good habit. I'm not saying that that's necessary to succeed in this course, but it will benefit you a lot. Often I've seen that what students do is that they take my lecture, they depend on the lecture notes a lot. Of course, internet is used, but these days internet has become the primary source, which is okay. I think it's a new way of learning. At least the traditional way was that you depend on 3 or 4 books, but probably internet does that job. and there are a lot of notes available, compiled notes available there. So that probably does it. It's just that I'm not very used to learning that way. But I'm sure it should be beneficial too. Beware of the notations when you go from one notes to the other. Notations change. Of course, you want to make sure that they are consistent with the notations here. If you're using your own notations, make sure it's very legible. The homework should be legible. It's not my responsibility to understand your answer. It's your responsibility to explain the answer. And at least that part, the decision stays in my. If I say I cannot understand, you cannot argue. I guess so somewhere I have to. It becomes my call. Okay. So that's office hours, class meetings. Oh yeah, class meetings. This course is scheduled for this room, and this is good. But there is another room, the conference room, which is usually nice. And I might, like if everything works out, if there is no rules on how many students can be in a room, we might switch to the conference room. Are you aware of the conference room? Are you aware of the students' lounge? Hriday? Yeah. Students' lounge, right across from the student lounge, there is a conference room. It has a nice blackboard. It is, as far as the number doesn't go beyond 4, then we are good. If the number of students goes beyond 4, then I think we might stick to this room. It's just more convenient. I haven't decided yet, primarily because I want to see if there are any rules saying that. Do you guys know if we are maintaining social? Is there a limit on the number of people in the
I haven't seen the masks.
Mask is the only thing, correct? Yeah.
Because they're bringing the number of people that are back on campus compared to last year. I mean, obviously they can't be doing the same kind of stuff.
Exactly. So probably we will go to that room. So be aware next time that which room you're trying for. You can always come here and then go there. I'll try to send an email also if necessary. We meet on Mondays and Fridays 2 times in a week. Usually this course, at least until last year, it was Tuesdays and Thursdays. But as I said, there was a conflict, and that's why we moved it to Monday and Friday. But that should not affect. That's what you're enrolled for. That should be. Textbook for this course. As I said, I don't say specifically textbook. Textbook means that you go one, at least that's the expectation students have, is that you go strictly through the material in the textbook. But this is more like references, and the best reference I found is by Erskine. So it's mathematical methods. Like this is the author, and the title is mathematical methods. Here and there, I will give you, even though all the contents we will talk about will be there in this textbook, but the notations might be different. And most of the time I saw, or sometimes I also suggest some other book. But again, I only suggest, I don't ask anyone to buy the books simply because most of the books are expensive. Yes.
I have a legally obtained PDF of it's either the 5th or the 6th edition of ArcPin that I can.
That should be good enough. Oh, you can share.
I can share.
Oh, perfect.
It's one of those that I think it's the early enough edition that now it can be disseminated legally. Yeah. I think I have from archive the Morrison best practice. Okay,
perfect. Yeah, so please. Yeah, please feel free to share. Yeah, that will really help. Again, I think for me doing this is slightly, I have this legal obligation that I can put only chapter wise. Like I cannot put the whole book, like example, even behind password, like on detour. First of all, on a public space, I cannot put it.
Right.
But behind password on a detour, I'm allowed to put some chapters. And at least last year, probably it was because of pandemic, or was it because of the rules? I don't know. They said that I can put the whole textbook as far as it is in chapters. So what I did was, for undergraduate physics, where sometimes the prices go really high, so I actually I had a PDF file from the publishers. I split it into chapters using this PDF pages, and placed the whole book on D2L. And I asked 3 times, not once, not twice, making sure that is this legal. And I was told by the library that it is. So hopefully it didn't make sense, because usually they do say that, okay, you can do a chapter, but not the whole book. You can one chapter at a time, how much ever you need. So that's what it is. So among you guys feel, and I've also noticed that more recently, it is good to have a group. However, I think there are the social accounts you have. Use your favorite ways to connect with each other. If it is local, a subset of groups or the full group, feel free to, I think usually it is good if someone takes an initiative. If you feel nice about it, take some initiatives and make some groups. There is this Zoom account available. Basically, it is my account. During the pandemic, I released that to the students. That is still available out there. Feel free to use that. That account is still active, but I don't remember the numbers. Go to the previous courses. I think you will have that, I think somewhere, or just ask me where it is. I think that's handy, because you can have long meetings there, and you can use the share screen where you can write things down. So feel free to do that. What else is there? What are the expectations? I expect differential equations. You should be familiar with it. Most of the things I try to go over from the scratch, especially this is a math method, suppose we should build things, but not everything, like simple vector ideas of vectors, matrices, determinant. Mostly differential equation. You should have solved a partial differential equation before those basic expectations are there. This will be recorded. This will be available on YouTube. That is, yeah, if you go to the course webpage, there is a link you will have that takes you to playlist. And in the playlist, instead of songs, you have these lectures. Basically, as you proceed, there will be about 40 lectures, not 40, right? 16 into 2, so about 30 to 35 lectures, and any more things if I place something in that. Yeah. Okay. About the evaluation, homework will be 30%. So midterm. So this is midterm. So there will be 2 midterm exams. So somewhere around, we have about 15 weeks in the semester. So after 5 weeks, we will have an exam. After the 10th week, we will have an exam, and we will have the final exam. So that's how the breakup will be. So this will be 20 plus 20, 20% plus 20%. So that makes it 40. So then there is a final exam, which is also 20%. What's the difference between final exam and midterm exam? Nothing, actually. It's pretty much the same. It's cumulative. Even midterm exams are cumulative. And that's, but having said that, I concentrate more on what has been studied new, but you're expected to know the whole thing. What's the difference between homework and the midterm exam? It's pretty much the same, except that homework could be long, very long. In fact, at least that's what I hear from students. I put in a lot of pressure. I don't hesitate if it takes 5 pages of calculation. I don't hesitate to put that in your homework. If it's in a midterm exam, I try to make sure that it can be completed in a reasonable amount of time, like typically 1 hour. So usually in a homework, you might have 10 small calculations going on. I'll build one calculation out of input. It doesn't mean that I'll repeat this homework in the midterm exam. I tend not to do that. It gives me a way to test people. So due to that reason, midterm exam does become hard because it's a new thing that comes up. But I curve things a lot. So, but primarily midterm is the way I judge people. I do know that you're taking help from people. So I do look in, I make a mental or it gives me insight into what you guys are involved in. So take homework very seriously. It takes time. Don't do it on the last day. It's not a good idea. So take this seriously. And of course, midterm also tells me that's again your responsibility, that if you're taking a lot of help from outside, how much independent you've got. It gives me an idea in midterm. It's okay if you don't get a full score, but there should be a sort of a correlation in that, how much effort you put into homework. Usually it shows up for various reasons. It's not about getting the whole homework correct. The way you go through it, it gives me an idea of what you're doing. So do the homework seriously and midterm exam. And these two are pretty much the same thing. Any questions on that? Homework and finals. Now, if you notice, this doesn't add up, right? That's 90%. And recently I've been saying, so there will be classroom quizzes. Now, what is that? Usually you must be familiar if you're in a high school, suddenly a teacher asks you a question and you have to answer that. That is pretty much what it is, but I won't address it to a student. I feel, at least I feel when I was a student, it was too hard on me when a student asked me a question. So I will raise a question or a thought and say that this is a quiz. And the goal will be that you write down the question. Sometimes the questions are not clear because I myself may not present it correctly, or it's just on the go question, so it may not be very clear. So the goal of the student would be to write down the question as you see it. In the recordings help in that matter because you can go and look into it. But the expectation is that you should not have to go to the recording. That's too much work. Go to the recording and search for the quiz. That's too much work. You attend the class, you just write down on the margin that, oh, this is a quiz. Make a try to gather what was discussed at that time. You take a half a page, write the question, and work on it. Now, how does it work? So suppose I ask you what is dark energy. You probably don't know what dark energy is, but the idea is that you look up the resources you have. Don't spend more than 5 minutes. Okay, so recommended time is 5 to 10 minutes for one question. But the hope is that you get excited about it and then you spend on your own, how do you say it? It's your responsibility that you're wasting, I will call it wasting the time, quote unquote wasting, in the sense that it is not going to help you with the assessment, but hopefully it will help you with your knowledge base. So that's the idea. You write the question down, whatever was raised in the class, and then when you're writing the solution, like half a page, don't spend more than half a page. It's just to prove that you really work. If you really could not get anything out of it, suppose I ask you, give me a proof of prime number theorem, of course, most probably you won't be able to give it proof. So you say that I didn't find anything, the proof for that, that's also okay. You write a question and I did not get to do anything, that's perfectly fine. How do I grade it? If you have written the question down, you get 4 points on it. Okay. It's a good bit of discipline in there. I've noticed that most of the grad students do very well. They are very good with, if you're told something, they do it in a sincere way. But you'll be surprised, there are always about 30% of the students who have difficulty doing this. And when you go to undergraduate courses, it's only 50% of the, or how many get it fully right? Probably only 25% who really consistently get submit all the quizzes. So it's just the discipline itself is part of it, even though we are not, I try not to assess on discipline. This is, I think, at the graduate level, that is not what we are assessing on. But still, I think this is useful mostly for making your thought going. Like, this is a place where I find go and read about, like, for example, in math methods, like I might be doing complex analysis and I want to introduce a concept which I don't have time to talk about. So I give it to you guys, okay, go and find this out in the quiz. So that's what I use it for. So it is to make you guys at least explore to a certain extent. So that's your quiz. So that's 10%. But then it does more than 10%. So in that sense, this is very important. This is also, let me call it equal. So there is a parameter I introduced, which is y. So, and now in this sense, this will affect all the grades. So how does it do that? Let's say that after the whole semester, you get about 60% of, so 60 out of, not 60 out of 90, this is 60%. Like this is actually total of 90, but I'm saying it is 60%, so how much ever it is out of 90. But then what I do is, so if there were no classroom quizzes, that will be your grade. You get 60% out of 100. But now I give you, I decide on returning back some points. So if I give you this 40 points back, you will get, everyone will get 100 points, right? But then I decide on a parameter called A. So that's a curve parameter. Usually it is less than 100%. So let's say that I decide to return you back 25% of all the points that you lost. So you scored 60 points, but I said, okay, this was a really harsh exam, and that is basically based on a semester basis. I have a rough idea of how much the students should gain. So I say that, okay, I will return back 25%. That will be 25% of that is 10 points back. But then comes the quizzes. You don't get that 10 points back. You get that 10 points only if you had a full score in the quizzes. So y will be less than 1. So out of 10, so this will be less than 1 or less than or equal to 1. And if you never submitted any quiz, that would be 0. Right? So if you never submitted a quiz, you don't get back the points that I'm giving you. So it's kind of a simple way of saying that what's the word? How dedicated you were in the class, or how much you participated in the course. Like did you ever go back and open your book? Again, I'm surprised that most of the time students come sit in the class and that's all. And this gets more often the case in undergraduate courses. Graduate level, I don't come across those things too often. But that should give you a clear idea of how you can. So don't take this too lightly because it does affect you. Whenever there is I have to gauge somewhere there is a boundary that, oh, should I be giving you a +2 or a -2? I'll use this. Oh yeah, he was very sincere in doing that. He always wrote interesting answers or something like that. So it gives me an idea that, yeah, the student has been working, going back and spending time on this course. That's the way I use it. From your perspective is hopefully that you learn the material. Okay. Homework, I said that it was depend on each other, or it's not necessary, but feel free to depend on each other. And I think by this stage, you learn a lot by interaction also. Hopefully you realize that during the pandemic, I think I hear the pandemic was not very popular surely among students. So yeah, do discuss and talk. There is a midterm exam on September 23rd, so reasonably far away. I think it's the 6th week of the semester. Yes, Ken.
This is 24th on the.
24th. Did I say 20?
Oh, you said 23rd. I'm sorry.
Oh, so no, 24th. Yeah, yeah. September 24. I think it's a Friday. Again, I look up the calendar and write it down. I make mistakes, but I do announce every week that this is the midterm exam. So by the time we reach there, we will have. Usually, it gets pointed. So do be. Yeah, I do make mistakes in these matters. So do correct me if necessary. Yeah, it is September 24th. I think it's a Friday. And we are only 4 students in this class. I think 4 students. There's a 4th student in the class. If there is a conflict, even it could be as simple as that it's your birthday and you don't want to take an exam on a birthday, feel free to mention it. But for a birthday, I may not cancel the postpone it. But if all of you guys agree, most of the times I agree, whatever the reason. I don't have to know the reason. If 4 of you guys get together and say that no, I want to postpone for some reason, and then you come to me, most of the time I agree, unless I feel that no, this is not, unless I feel it's very unreasonable, I will approve it. And the same thing holds for homework also. If all of you guys think you're going to benefit by postponing, it's okay with me. But again, remember that things pile up. If I postpone the homework, that doesn't mean that the content gets postponed. I'll keep teaching, right? So eventually, after just by within 3 weeks, that might be too much homework, and you may not be able to catch up with it. So be responsible in this part, I think. And again, in graduate level, yeah, I do postpone. I mean, students do ask for it. That's understandable, but don't do it take it too far. I'll, especially in the first few weeks, at least try to catch up. Eventually, you will get into the stage where homeworks are not working out. So, so yeah, you'll see as we go. Okay, any questions? There's a syllabus attachment, which is something prepared by the university level administration. I'll let you guys go over it, especially the COVID things might be good. If you have anything about dropping the course and other things, so this is a good place to look for links. That's something. I gave you the homework. Just when you look at it, it may not be very obvious, especially the notation. It's not expected that every notation you should be familiar unless you're taken this. This is a reasonably standard notation. If you're a physicist, most of the people in the physics department, if you have taken the course, they will understand what exactly this is. But if you've never taken it or never used this, it is also possible that you just don't understand what's written in there. But that's where the course comes in. Okay. So the things that you want to remember for now is that there is a homework 1 that is due next Monday, which is August 23rd. So Monday. What time is it due on Monday? It can be made due in the classroom or in the physics office. If it is in the classroom, it has to be done during the class time, right? Preferably before the class time. But it's okay if you submit it by 4:30 p.m. in the physics mailbox. Is that clear what I mean there? Not physics, in physics mailboxes, right? So if you have been to the physics office, right across from the physics office is a mail room. Right? Basically, there is a Xerox machine or a photocopier and a printer. And on your right side, as soon as you enter, you will see small boxes. Each of you should have a mailbox for it. If you guys are teaching, you should check that because sometimes students drop something. It's your responsibility to check your mailbox. I have a mailbox in there, so you can just drop your homework in there. Your case, Yes.
I was gonna ask if you would have the option of D2L.
D2L, do you want that?
You do email if you wish.
Yeah, your case is different because I understand that you will not be there on the typical days. You can have it go to the next day if you want, whenever you're coming in, or you can email it to me. Okay? So your case is special, but those who are here, I don't want the D2L thing because it's more work on my part to just grade it. So I would like physical grading. Same thing with quizzes. That's the difference between last year and this year. Last year, you submitted it on D2L. So you take a picture and submit it on D2L. Here, and this is strict, the quizzes has to be submitted right before the class begins. Even a few minutes late, I will say I will not accept it, but typically it's once in a semester, that's okay. I'm pretty lenient about it, but these are due right before the classes in paper. It's very easy for me to grade it within 2 minutes. It gets over. If it's on D2L, I don't know how much time it takes. Efficiency is significantly lower there. So this is due right before the classes, and I'm strict about it. Like you cannot submit a quiz from last week, this week. If you missed it, you missed it. That's the whole idea of this, that you have to be disciplined. Your case again.
I can always submit via email so that you see that I have it completed and then just give you a hard copy.
Exactly. That will really help. Yeah. So
I'll
I'll just, the moment I get a email from you, I'll save it, but then I won't deal with it. Like I won't try to grade it on that. And then in the next call, whenever you're here, put it in my mailbox. That's good enough. So you met the deadline, and then I have a copy of you. When it comes to homework, why 4:30 p.m.? Because the physics office closes at 4:30 p.m. So once it closes, it's probably difficult for you to open. I don't think you guys have access to that. If you find someone going into the room, even after 4:30, it's okay with me. But if I collect it at 4:30, then that's a deadline. Right? But by some chance, I don't collect it until the next morning, which is unlikely because usually I do take it before I leave. But if I wait until the next morning and you happen to enter the physics office using someone else's help, that's perfectly fine. I don't know about it. Feel free to do that. Sometimes I've seen students dropping it under the door of my office. That's okay with me. I don't mind it. But beware that sometimes when you push it, it might go somewhere else, go under the table. That's not my responsibility. Okay? It doesn't happen again. So most of you guys push it don't push it hard. So I see it. So I'm okay with it. If it's few minutes, I don't want to be very harsh about it. But don't make 4:30 9:30. Right? So that's 4:30 plus or minus 5 minutes. That's perfectly fine. And these days, since you got used to the pandemic, feel free to say that, oh, this is by email, but then next day come and give me the hard copy. Email is a proof that you finished it, but I will prefer a hard copy. It's much easier to grade that way. Yes. Yeah.
For the quizzes, do you want us to put them in the mailbox too? Or
No. Quizzes here.
Okay.
Quizzes here. Again, if it is before, for some reason you prefer it, that's okay. Or let me make the quizzes very clear. Quizzes, I want it in here, like in the first 3 minutes of the classes before I start teaching, right? So that it's just easy to handle because there'll be a quiz every day. It's just management is way easier. I won't give a extension to it because then I have to follow up, right? You say, oh, you extended this. So I'll just be strict with that no late submissions for quizzes, no extensions for quizzes. If you miss the quiz, you miss the quiz. And if everyone misses, that's different. Right? So then there is no quiz on that day. Right? And sometimes I don't ask a question at all, and then there is no quiz. If I don't ask anything on a day, you don't have to write that there was no quizzes on that day. Which is, I understand that there was this confusion as to when I was very regular with the quizzes, like what do you do? Because especially during the pandemic, I open a column with quiz for this date. then students start very clear what you do. So then it's okay if you want to submit a paper with there was no quiz today, but there's a good chance that there will be no grades for that at all. But if one person submits it, then there is a grade that person gets and others get 0. So that's the way it works. Okay, that's pretty much and this. Is there anything else that I have to say about this 4:30 p.m. in physics? Yeah, and quizzes before class or first few minutes of class. Class begins. Oh, screw that. And the second thing you want to remember is midterm 1, which is way away. It's 24th, and it's Friday. And more recently, I have been having this in class. When I start, at least I have encouraged students to have it in the evenings, and then without any deadline at all, you can take as much time as you want. But eventually, at least in the last few years, I've come down to just have it in the class. It's just much easier because most of the students are available. But again, you're a small number of students. If you guys really think that you will benefit by having it in the evening sometime with no limit in the sense that you start at 6 o'clock and then you can take your time. But again, my usual statement is that this is what we used to be told when we were grad students, that if you cannot figure out a problem, at least the kind of problems that I give in 3 hours or let's say 2 hours, probably you will not figure out. So give up at some point. Don't stay for 6 hours for an exam if you decide on that. I say that because I really had students, like graduate students can be very dedicated and very committed to it. I've had students who started the exam at 6 and it's 11 o'clock in the night and 12 o'clock, and there is no hints of movement that they're going to submit. So eventually I had to say that no, you should submit. So I would say let's not make it infinite time. So so yeah. So any other questions on that? Yeah. Again, you can tell me about that later. By default, we will have it in class, but if you guys discuss among each other and you say that, oh, no, I like the evening idea, then we can float it around. Everyone should be available. That's the only condition I have. And so that's what it is. Any questions in general? So maybe we can start doing something. We have about half an hour, right? Less than half an hour remaining. So let's start with what is basically vectors. The basic idea is just to do vectors of, but using a notation. And since we use it so often in almost every course, it's a requirement that you should understand this. But it's mostly just a rule. So it's not conceptually deep. That's what I would say. Like there are certain concepts that are deep, like for example, complex numbers, complex analysis, I think is very deep and has a lot of rich material in it. If you think hard, by that what I mean is that if you think hard enough, you might even today, after 200 years of its existence, even today come up with new things, which is not observed by others yet. So in that sense, it's very rich. But sometimes things are just mundane rules. You just have to follow the rules and you get that. So what we are doing here, I think, is just set of rules. It's convenient. Everyone uses it. It's like everyone uses it. So you're also supposed to be familiar with it because they will talk in that language and you have to pick up that. So in that sense, it's mostly getting used to the existing language or rules. We'll call this vectors. And What's the difference? Or maybe I should ask, yes, vector field. Maybe that can be the quiz for today. So what is the difference between a vector and a vector field? Give some examples. So what is the difference between a vector and a vector field? Can I ask? Are you familiar of the difference between a vector and a vector field? Or let's begin with vectors. Give an example of a vector.
Vector is something with a value and a direction.
And a direction, good. And an example would be?
Temperature. No, the temperature.
Temperature would be not a vector. It only has a number, right? It usually doesn't have a direction. Yeah.
Velocity.
Velocity has something that has a direction and a number. But notice it's just one direction and one number, right? So that's a vector. Now, what's a vector field?
The gradient of the vector.
What is the gradient of a velocity, let's say? I said velocity has just one number, one direction. When you say gradient, it has to change, right? But it has only one number and one direction. How will it change?
Acceleration.
Oh, yeah, good point. That's changes in time, right? Let's say, yeah, you brought in a time in there, so you can make a change in time. Yes, agreed. But if you fix the time, let us say, just to take away the constraint, then there is nothing to change there, right? But you said gradient, so that's a good point. That gradient typically has to do with, first you said time, change with respect to time, velocity at one time, velocity another time. What's the difference between the two, and divided by the time, that's acceleration. But what if you have a velocity at one point and velocity at another space point? Not in the time, but that's not okay, right? I mean, you have one particle, you cannot have two velocities there, right? You have one particle, you have one velocity. So think of something that has a point. So for example, this is space. Let's say this is a line, right? So there is a velocity, so some vector here, and the next point, it changes. Think of an example where there is a direction and a number associated with at each point in space. This is a line in principle everywhere.
Magnetic field.
Magnetic field, very good. Or an electric field. That's the classic example of a field. In fact, the word comes in electric field, magnetic field. These are at each point, you have a vector associated with this as a direction and a value associated with that. The next point, it might be different. Its direction can change, its value can change, all can change. That's the vector field. A vector field is a space dependent, is a vector at each point in space. Infinite vectors, which is triggered, and then you can talk about the gradient. Oh, what's a change in the vector as you go from one point to the next point? So gradient comes into the picture, but that's the next step. So that's the simple idea of a vector field. So, but let's go back to vectors now. So for now, just vectors. So a vector, as you guys said, so typically the notation is A with a vector, especially when I'm writing something on the board, I have to clarify that this is a vector, so then I'll write an arrow. If you're in a textbook, you just use a bold symbol, right? So you just have a bold sign. But when you're reading a textbook and then you do a homework, remember that you don't have the bold feature in it. So most of the time I see the students don't write the vector sign. You better be very bold in your, like very bold in the sense you have to really make your letters really bold that I can realize it, because it is not okay to not write the vector sign. Okay? Either you make it bold, which is what textbooks do, or you make a vector sign. if it's a two-dimensional vector, then typically we say there is an x component, which I'll call A1 in the I direction. So this is x hat, for example, right? So this is, let me clarify. This is A2 and the J hat direction. These are called components. So let's clarify. So this is a x. So there's two orthogonal directions. It doesn't have to be the x or a y. So let's say this is I. This is a direction. This is itself a vector. It's a unit vector. So that clarifies that there's a direction, and there's this j. And a vector is something starting from the origin and going to another point here. It has a head at the point where it ends, and it starts from the origin. This length is called A1. So that's this length here. And the vertical length is called A2. So that's the way you would write it. Now notice that if you're in rectangle, so these are sometimes called basis vectors, I hat and j hat are called basis vectors. If it is clear among all of us that we are going to be working in a particular basis vector, then we can drop this basis. Basis vector has a very good meaning, right? It is so much distance in this direction plus so much distance in the other direction. So the directions are very important there. Those basis vectors are very important. But there, most of the time, we always work in one particular basis. If that is the case, then you can start dropping it. I said this is a language, right? So this is a rule. So we are assuming that we are working in the rectangular coordinate system with x, y, and z. It's not spherical coordinates. Spherical coordinates have their own basis. We're not working with spherical coordinates. We're working in rectangular coordinates. So this is now not really equal in the sense that we are killing the direction sense, but this is a notation that I can write this just as A1 and A2. So that's it's basically less information being given, which is not appropriate, especially if you're talking to someone from another planet who has never taken any kind of rectangular coordinates in here. Then this is not sufficient information. This is not equal. Right? It's not sufficient. There is a notation in there that this is I and j. Great. So that's these are called the components of this vector. It's very clear. In fact, you get even better, or I wouldn't say better, even worse at the communication part, that you get lazy to write that much also. And I will say that it is laziness, but there's a lot of advantage by doing this. That's why you typically do this. You say that, forget A1 and A2, I'm just going to say this is AI. Okay, so that's where the index comes in, index notation. So AI, and I here means that this is 1, 2. It could be either 1 or 2. And we will typically work with abstract quantities. We will never put in the numbers. If I had to put in the numbers, then this is not a good notation. Then I have to go here. There will be 2 numbers associated with it. Then I have to provide the 2 numbers. Here we will be doing the algebra of vectors. And when we are working with algebra, it's an abstract quantity there. Then this is convenient. This is a quantity that has 2 components. That's the way to look at it. One good thing is that it's very easy to go into higher dimension in this, keeping the rectangular basis in mind. Then there are 3 components, A1, A2, A3, and I just have to say 3. All the algebra remains the same. I can go to n dimensions. I don't even have to fix to 3. I can go all the way to n dimensions. In fact, whatever you work with in 2 dimensions, because you will never, I said, you will never specify these 3 components. You will always work with AI. And it doesn't matter whether I goes from 1 to 2 or 1 to 3 or 1 to n, most of the algebra will remain the same. Most of the time, I don't say all the time. And one thing that doesn't say the same is cross product. We will deal with cross product very soon. Cross product, notice that you have if you have two vectors, the third vector is out of the, is perpendicular to that. So here is the second quiz question for today. What is the cross product in 2 dimensions? Okay, is that clear? So first let's begin with, so the question is cross product in 2 dimensions. That's okay, right? Cross product in 3 dimensions, we clearly know that's what we, whatever insight or interpretations you have about cross product, that's 3 dimensional. It's purely 3 dimensional. Question comes, what about 4 dimensions? 2 dimensions is an easy answer, or I wouldn't say easy. With a little thought, you can immediately come to a conclusion what the cross product is in 2 dimensions. But what is the cross product in 4 dimensions? How will you define a cross product in 4 dimensions? Again, that's an example of a question which is depends on how far you explore. Right? It can take a long time, but it's a good thought. It gives you a, oh, I never realized that, oh, I could think about 4 dimensions, right? So how do you do that? So that's a example. Okay. So with this now, so now this is your vectors. Let's say we typically do algebra, right? So let's say add 2 vectors, right? So add or subtract for the matter. So you will say A plus B is equal to C. Again, typically this notation, and this is called an index, right? So I have not yet come to what is called an index notation, so I'll do that in a few minutes. If you, this is an algebraic relation between vectors. Again, I said that we won't talk about, we won't specify numbers too much. So what we would like to do is that if A plus B is C, then each component adds, right? That's how we add vectors. The components add in the vectors. So this is also okay to say that the ith component, that means the second component of A plus the second component of B is equal to the second component of C. Notice what's the difference. Whenever I write a vector equation, there are how many equations in it? It depends on the number of components. If it's a 2-dimensional, there are 2 equations in this, right? X component has 1 equation, Y component has another equation. Here, if you're in 2 dimensions, there are 2 equations. Set I equal to 1, you have 1 equation, right? So what I mean there is, this is equal to A1 plus A2, sorry, B2 is equal to, sorry, 1, right? I set I equal to 1. So A2 plus B2 is equal to C2, and so on. If it's 3 dimensions, there are 3 equations. That's what this means, right? This is called a free index in the sense that every term of this has it, right? That's usually a very good check for your equation. If that is a free index, it has to be there in each term. If one term has I, each term should have I, right? That's like if you add 2 vectors, if this is a vector, this also better be a vector. You cannot add a scalar to a vector, right? So if there are 3 components to this, this has to have 3 components. This has to have 3 components. In that sense, I each term. So the moment you see it, so if someone tells you that AI plus BJ is equal to CI, that's wrong. Okay, because this is like saying that the moment you write a different index, then it's not very clear what does it. So A1 plus B2, then the rules are not very clear. So here the point is I is the same. The whatever I you use here, you have to use the same I there also, right? So there are some implicit rules of the game that the X component plus X component is equal to X component of C. So that's what we are saying. Reasonably simple once you realize what is going on, but in the beginning, when the rules are not completely written down anywhere, there is nowhere where you write every possible rule in there. If it's subtract, that's the same thing, right? You add or subtract, right? you just vector algebra works pretty much the same as, and all the addition, interpretation, all that goes through the geometry of vectors, addition, that I won't get into it. You guys can should go over and try to review. Okay, so that's good. So addition and subtraction is relatively easy in vectors. Then comes the dot product, right? So, or the scalar product. So scalar dot product. And how am I doing with the time? 43. Yes, 7 minutes. Okay. Right. So let's go back and remind ourselves of what scalar product was. This is A dotted with B, right? So that dot is important, right? That tells you that this is a scalar product. It gives you a number, right? It gives you, doesn't give you direction. It gives you a scalar. That's the word scalar coming in there. How do you do this in terms of indices? You would say, I will do A1 times B2. I will multiply, sorry, A1 times B1. I multiply the first component of the 2 plus I'll again multiply the second component of the 2, and that's what. If it's a 2-dimensional space, then A dotted B with is just this. If it's 3-dimension, I just have to add the third one. Right? So that's 3 and so on. If there was n dimensions, I can keep writing that until n. That's your dot product. Is that clear, familiar? It should all be. And then you will say, oh, okay, how do I now? I want to write it in terms of indices here, right? We came up with this lazy feature that I can encode this 3 indices, three components just using one index. Here, how do I say that? If I want to write it in terms of index, I realize that, oh, this is a pattern, 1, 1, 2, 2, 3, 3, and there is a sum over it. So I say that's equal to sum over I going from 1 to 3, let's say, or in principle n, right? If it was n dimensions, and AI times BI. Right, and then you see that I get this index, and so somehow this is what is this is how it works. Clear? And now comes the notation. This is the real lazy part, or this is what makes it powerful also. That you say that you drop the sum. Okay. You drop the sum altogether. Now that's a notation. Okay. So this is called index notation. But that should really bother you, because if you drop the sum, how do I know that I've summed it at all? Right? If you're telling to someone else, how do you, like, for example, you're talking on phone and you say that this is equal to this, and how do you explain to them that this is actually true? The idea is, so the rule is that if an index repeats, then it is summed over. And since I repeats here, it's understood that this means A1, B1 plus A2, B2 plus A3, B3, which means to say that I have not clearly said. So that means AIBI, AIBJ is not A dot B. This is not scalar product. This doesn't repeat, right? So this is a different entity altogether. We will see later on that this is actually not even a vector. We will see that this is actually a tensor. Okay, we'll come to that. But let's go back here. What is the significance of I here? There is no significance of I, because what's the difference between this and this? let's say j is equal to 1 to 3, aj, bj, right? If I start from here and try to reach there, they're the same. It doesn't really matter whether I use j or k or anything for that matter. And in that spirit, this is also aj, bj. Okay? But that really should bother you. Oh, what does it mean? Like I, j, right? Earlier I said that I was free here. So we will call j here is a dummy index. A dummy in the sense when you're integrating on something, remember, so this is a good example to have in mind. So when you're integrating f of x, g of x, let's say going from a to b, this is the same as a to b dy of f of y, g of y. This is just a running parameter, right? It doesn't matter. The same idea here, this is just a running parameter or running variable. Whether I use I or a j, it doesn't matter. So that's a dummy index. Here, j is not a dummy index. You call it the free index. So let's say there's another terminology associated with it. It is called the free index. For example, f of x, if there was no integration, x is a true variable, right? X has a meaning there. But the moment I integrate it, then I can use x or a y, it doesn't matter. So that's exactly the same thing. There's a free index, I, and there is a dummy index, which is not relevant. So let's stop here. It's exactly 10:50. We will actually make the rules for cross product. We will introduce new symbols to deal with dot product, and we will go from there. Okay, good.